Good morning, folks. This is Mr. Walker here, coming to you with our next lesson, start of our new unit. We are talking about reviewing radical expressions. It's been a minute since you've seen it, so let's talk about it. All right. First off, you probably got this somewhere in your book, but this is just a quick review over these basic perfect squares and square roots that we use all the time. So, a square, when we're looking at it, is something times itself. So we got everything from 1 to 12, and these here are the basic perfect squares that we generally deal with. We don't really have to go too high up, but if you do, you got the calculator to, back you up. All right, first off, 1 times 1, that's 1 squared, which is 1. 2 squared, that's 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Then we got 36, 49, 64, 81, 100, 121, and 144. Now, all of these over here were us multiplying that number times itself to get to these answers. These square roots are us looking for what number times itself gives us what's underneath here. All of these here give us whole numbers, but not every square root does. So keep that in mind. So running down the list, we got 1 again, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Make sure you keep this in mind because we're going to be messing with this a lot this unit, okay? So let's get to this definition work. All right, so first off, what are we talking about? We're talking about radical expressions. So let's get to the first part here. Radical expression is an expression which contains a root. So this symbol right here, that's our symbol for a root. So inside of a root, we got two things. We got the radical, and we got the number underneath it, which is the radicand. They call this symbol either the radical symbol, the root symbol. Most of you guys probably recognize this as the square root symbol, but there are higher, different types of roots as we go further on into math. We're only going to be dealing with the square root one for right now, though. Okay, so going in, we got to talk about how is a radical in simplest form. So simplest form when we're dealing with radicals is so that we don't have to deal with some of the decimals that can come out for non-perfect ones. So when we want to get this into simplest form, we have to make sure that the radicand contains no perfect square factors. We also have to make sure that the radicand is not a fraction and that are no radicals in the denominators of a fraction. So if we see a fraction or any radicals that are in the denominator part of a fraction, we're going to have to go through some steps to fix it. We also want to make sure that there are no perfect square factors of what the radicand is that we can take. So we got two steps that we're going to go through for this. But before we do, let's look at a couple of examples. We got things like 5. That's a good simplest form radical. This right here, square root of 14 over 3. That's also a good perfect square. Sorry, not perfect square. A good simplest form radical. 33 would work also because 33 doesn't have any perfect square factors in it. So this would work too. And same thing with 6. So when we're looking at things being on simplest form, the number underneath it can't be broken down into a perfect square and something else. And it cannot be in the denominator of a fraction or just have a fraction underneath the symbol in general. Okay. All right. Let's get into some steps so that we can start to simplify. All right. So some steps to simplify here are find the largest perfect square factor of the radicand. So we look down the line of all our perfect squares and we mess with it. Okay. So depending on what the number is, that's going to be what we're going to be dealing with. So let's deal with our number. Our number that we're going to be messing with is 24 underneath this. Now, 24 is not a perfect square. Okay, you can notice that because it's not in this list. So when we look for the largest perfect square that can go into this, we're looking for what we can divide from this list of numbers with 24. So the only one of these that happens to work for us to divide and get another factor would be 4. All right, after you find that number, next up, you're going to have to rewrite this radicand as a product of that perfect square and the other factor that makes up that number. So in our case, we know that 24 is made up of a lot of different things that you can multiply with. But for our case right here, we're messing with 4 and 6. Now, since we are multiplying two things underneath the radical, that's also the same thing as having two radicals that are multiplied with each other. Now, next step that we got is we're going to simplify by taking the perfect square factor and reducing it. So we know 4 here, that's a perfect square. So that means that we can take the square root of 4, which happens to be 2. And that 2 comes outside of the radical and is right next to our 6 because those two are multiplying and are the same thing as whatever we had from our beginning. Now, if you wanted to go through and check to see if these two are the same, you would just go through and use the calculator, plug this in. If you get the same decimal as this, you did your math right. All right. Real quick, real slick, real easy. Let's talk about our next bit of simplification. Now, this one's called rationalizing the denominator. You have seen this in Algebra 1 because I've seen some of your teachers talk about that already. So just be aware, take your time, you'll be fine. So there's 3 steps. Not 3, actually, 2. First off, if you got any radical in the denominator, like how we see with this 5, we got to get this thing out. So to do that, we got to multiply the numerator and denominator by that radical that will make that denominator into a perfect square for its radicand. So we're trying to turn the denominator into something that you could take the square root of. So I know for me to take the square root of whatever's underneath here, I can take this 5 and multiply it by another 5 that's underneath the square root. So you multiply both the top and the bottom here by that new square root of 5. Whatever you do here, you just go through and deal with these like they're fractions in general. So you multiply up top times the top, bottom times the bottom. Over here in the top, we got 4 times the square root of 5. In the bottom, we have the square root of 25. Now, after that, you simplify. So anything you can take the square root of, you do. So you can take the square root of 25, being 5, and the top, that's already done up, and there's nothing else you can do. So you leave that like it is. All right, folks, you got some practice to do. Today was a short video. I'm not going to go through these all with you. These are going to be part of your practice questions to work on quizzes. So I'm going to catch you guys later. Thanks for your time.